All right, for the last of the Module 7 videos, this is when we're going to do our calculations with the speed of light. So we have met all of our other objectives, but now we're going to talk about the relationship between the speed of light, and we abbreviate it with a small c, and its frequency, f. Sometimes, actually, in a lot of literature, they're going to use the Greek letter nu. It looks like kind of a V, so sometimes you'll see frequency as a nu, or an F in this case, and wavelength, which is the Greek letter L, lambda. So the relationship between the speed of light and its frequency and its wavelength is something that you need to memorize. You need to know that the speed of light equals the frequency times the wavelength. So memorize that equation. Now let's work with that equation. And to work with it, sometimes we are going to give you the frequency of a photon, and a frequency would be f, or we're going to give you the wavelength, and we're going to ask you to calculate the other one. So at any given energy or frequency of a photon, you ought to be able to calculate the other, because the speed of light always stays the same. The speed of light is going to be 3 × 10⁸ meters per second. So here is how that same formula can be rewritten in case you're not all that comfortable with the algebra. This is the form of the equation that I have printed up there for you. The speed of light equals the frequency times the wavelength. You could rewrite this equation. Let's say that you want to figure out what the frequency is if I give you the wavelength. You could take the speed of light, divide it by the wavelength, and that would give you the frequency. Or let's say that you know the frequency, but you want to know what the wavelength is. You could take the speed of light, divide it by the frequency, and that would give you the wavelength. So it takes a little bit to get used to using your calculator, because these are just going to be crazy big old numbers. You're talking about the speed of light itself is a 10⁸ number. The wavelength are going to be very, very short a lot of times. Here is a wavelength 4 × 10⁻⁷ meters. We'll always keep our wavelengths in meters. And our frequencies are going to be very, very large numbers often. Like here is 7.5 × 10⁻⁴ frequency. That's per second. That's how many times that wavelength goes up and down in a second. So if you want to calculate this case, the frequency, the speed of light always stays the same. So now I'm going to use this formula here, speed of light divided by the wavelength. So the speed of light divided by the wavelength will give me my frequency. All right, and so our next calculation is going to be, if we talk about the frequency or the energy of a photon, we could interchangeably calculate the other. So we have to introduce another constant. So our first constant that we introduced was the speed of light, and we use that in this equation here. The next constant is Planck's constant. These are the smallest packets of energy that can exist. That's what Planck's constant is. And that is often abbreviated lowercase h. And that number is 6.626 × 10⁻34 joules per second. Crazy number, but that's not a number you have to memorize. Wiley will give it to you, but you have to know how to work it. So if you know what the frequency of a photon is, so let's say that your frequency is this, 7.5 × 10⁻⁴ 1 per second. You can take that frequency, multiply that by Planck's constant, that's F, and that will give you the energy in joules of that photon. Now, one of the other ways that you could write that, and you don't have to remember this, but I'll just show it to you. You could also, if you're given the wavelength, you can also calculate the energy this way. You know that the frequency is nothing more than the speed of light divided by lambda, so the wavelength. So if I take the speed of light, divide that by the wavelength, that will give me the frequency, which is, I could substitute frequency right there, multiply that by h, and that also would give me the energy of the photon. Okay, so let's say a little bit about photon emission and understanding it. So photon emission occurs when you excite an electron, in this case of a hydrogen atom, it goes to a higher energy state and then it relaxes down to a lower energy state. And as it goes from that higher to lower energy state, it emits a photon of a certain energy, all right? And so that's what we're talking about here, about the energy that's emitted. And here's another little cartoon showing this is our hydrogen glass tube. We are running a current through it. We're exciting electrons in there. As those electrons are cascading down from higher to lower energy levels, they are emitting photons of specific wavelengths. They also have specific energies and specific frequencies, but here we see them in terms of wavelengths. And so if we know what the wavelength is, and we can get that off of a spectrometer, then we can calculate the frequency of that photon as well as the energy of that photon just using the chemical equations that we just went through. All right, well, that is the scope of Module 7. A lot of different things. We kind of divided it up into 3 different sections. The first one, we just simply talked about the electrons, the protons, and the neutrons, and isotopes. The second section, we have talked just about the relationship between the speed of light and its frequency and its wavelength. And then the third section, we have talked about the actual configurations of electrons in orbits and being able to write out those configurations. And that's the scope of Module 7.